All right, so we were members of Crew 99. We started as a group interning at the NASA Space and Exploration Academy in Mountain View, California in 2010. And then from that, our 13-man group, we decided to carry on our group project to the Mars Analog to MDRS. So that's our 6-man crew ended up there in 2011. So this is our crew. All of us came from varying backgrounds. I believe I was the only one still in undergrad at the time. Oh no, I guess some of us were undergrad, but we got Secret from MIT, myself from Virginia Military Institute. Kevin was, I believe, transferring to Arizona.
At the time, yeah.
At the time, obviously Max. And then Donna was, yeah, she was transferring over to Arizona. And then Andy was starting up at MIT. So all of us kind of different backgrounds, different organizations. Donna was our crew commander. She had done NDRS previously, so this was her second time. And she also kind of was the drive to convince us all to go. I was the XO and chief geologist, also the science team lead for our main project. Max and Kevin did engineering of the HAB. Secret was our astronomer, and then Andy was kind of just general scientist, I believe.
Yeah, I think officially she was officially also the press agent.
Yes, I believe so. Yes, all of us kind of had varying roles while we were there. We were just overall excited to be there in general. So we moved on towards our exploration towards MDRS. So this is our initial project. This is Max and myself. We are working on Lambda, which was a project that we found research on from an Argentinian group that decided to use a microbial fuel cell to try to detect life. So usually you put microbes into a fuel cell, you produce power. If you reverse that, if you put a soil sample in that you suspect to have microbes in it, you can then, based on whether there's a voltage or not, determine if there's life in the sample. So we did a very crude experiments while we were at NASA, and then we continued on once we got to MDRS to making an actual full-scale model. So in this, there's two chambers. There's the anode and the cathode. You have using carbon as the anode, to pull the protons from the one side to the other, and using a semi-permeable protein membrane between the two. So in one chamber, you have, you take your soil sample, you make a slurry type, and the other side you have a liquid that will pull the protons towards it. And all of this gets set up we actually had the entire thing in a carryable box with its own power source. Using the laptop, we were able to document the voltage going from one side to the other over time. So we went out, we searched for places on Mars that we thought would have the most probable places for life. We used a lot of riverbeds in the canyons to collect our samples from to increase our chances of finding microbes. Also, I mean, we found a lot of awesome geological features showing, yeah, there was water here at one point. So once we got our samples, we made our slurry. One of the big problems that we found was we needed a way to agitate the sample so that all the sediment wouldn't just fall out to the bottom. That's where we start getting really creative on how do we create this agitation. Max will show you some pictures in a little bit. But once we were there, we were able to create a voltage from the initial sample. You then take the sample and you, using the heat source within it, you sterilize it, and then you do a background sample to see is the voltage different the first time and the second time to determine whether there's life. We were able to determine a voltage at the beginning, and there was a different voltage at the end. However, we kind of had some problems with the setup where there was leaking and the water started to evaporate out, so we couldn't determine officially if that difference was because of that evaporation or not. So we actually took samples back, and Donna and a few others communicated through. She continued the project with continued to do it at home and was able to determine that the voltage we were creating was coming from the microbes and stuff. So that was our group project. Each individual had our own projects we were bringing from the university. came from. The project that I was interested in was, it was a tunneling project. So it's reasonable to think that when you send people to Mars, radiation is obviously going to be an issue. So you want to find ways that you can protect yourself using the land itself. And on Earth, when you're about to, you determine whether a rock layer is suitable to build a tunnel, you use something called the rock mass rating. You're using 6 different principles of the rock itself. You go out and excavate, and you actually analyze the bedrock layer to determine on a scale from 1 to 100 whether the rock is suitable to put a tunnel in. So I wanted to determine, is it something that's feasible to do on Mars, using spacesuits, using the technology we have at hand to actually go out and excavate and determine whether these rocks would be suitable, something that's completely practical when you send the initial groups of Martians out. They want to be able to go out and survey whether these layers are suitable for tunnels. So we went out to several different sites, my team and I excavating, to determine whether there were layers out in the rock as well that would justify putting tunnels in. So there was a lot of terrain that we had to overcome, kind of climbing up to get to the layers in question. We did a lot of surveying, measuring, using all the tools that we had on hand. And we found 3 different sites throughout the swell we were at that we determined would be suitable to build some tunnel in. The rock layer was strong enough that it would be a good location. So these are just a few of the areas we were excavating. And I like the app that you had showing the different angles and stuff. We used very crude original geological surveying equipment. But that was my project, and I'll turn it over to you next.
So you already spoke about the HABS design in general. I'll try not to rehash that. But when we were there, this was before Musk Observatory had been moved back down to its new foundation down by Green Hab. It was still up on the ridge when we were there. You can see the water supply tank right here for MDRS. We got that filled along with the crew that was leaving right before us, right before we left. And that's 2 weeks supply worth of drinking and cleaning water for a single crew of 6. So it's a good scale of how much water you need to keep in a habitat like that. This is the EVA room. See just the type of equipment that we keep on hand. You did speak about the suits. They're obviously not actually airtight, but they do have a circulation system to keep the air fresh and cool inside the helmet. And they're very inconvenient, as a proper simulation suit should be. Our very first EVA, we went out to see a geocache, which was only a couple hundred meters away from the HAB, so not a very long trek, just for a chance for us to get a feel for the spacesuits. And with a geocache, obviously what you do is you leave something there and you take something away from the cache. So we brought a pin of our academy class from Ames, and spent a good 5 minutes trying to get it out of the damn pocket, because none of us had realized that we wouldn't be able to get into our pockets when we were wearing gloves. So it's inconveniences like that MDRS and the flashlight station are so good at teaching you to think about. It's the kind of stuff that we go there to learn. Is what kind of stuff are we going to encounter that you wouldn't have thought of because you're so used to thinking in terrestrial terms. It's one of the staterooms. I actually really like the design of MDRS and the way it sandwiches these, where the bunk for this room is up here. The bunk for the adjacent room is under here. They are actually stacked like Tetris blocks. It's a very clever utilization of space. I really admire the architect who put this together. This is the common lab area, reasonably well stocked. It was actually pretty surprising how well stocked it was. But it doesn't have everything you need, as you learned with the centrifuge and as we learned with our own apparatus. Which you'll see. This is the common living area viewed from up on the service deck. So yeah, so you cover most of this. I won't go over it in detail. So when Greenhab was there, when we were there, Greenhab was not really being used for any cultivation. It was kind of being used for the grey water system, but the toilet itself wasn't fully functional when we were there. We were actually dumping our washing waste down the toilet to use it as whenever we needed to flush. So I understand Greenhab was kind of supposed to play a part in that. Thankfully, it was not fully operational when we were doing that. So it was really just used for storage when we were there. Here's some of the duckweed that they were growing in there. And then here's the power station that you mentioned. We had, our generator had more than a 6-hour fuel supply. All we had to do was go out there every day and put together an engineering report on the status of the fuel that was left, so they'd be able to send out a resupply when necessary. So they had a gas generator, which gave us no problems. Like I said, we designed our experiment, the Lambda package, to work with the expectation of power losses. We gave it an uninterruptible power supply, we gave it a day's worth of power reserves built into it and never needed it. The power was completely uninterrupted the whole time we were there. Then our transport, the ATVs, ABA, Musk Observatory, and the telescope. So Sucrit was our principal astronomer, but we ended up doing a lot of the astronomy together since I'd actually been in an observatory before. We got some nice pictures of Saturn and Titan, and we actually had the telescope play a part in one of our experiments with high-altitude balloon work, which was what my specialty was, and I'll show next year. So the last night that we were there, we did my project, which was a high-altitude balloon study, which was meant to, in a Martian analog environment, you send a balloon up on a very long tether and then reel it up and down, and kind of get vertical sections of the atmosphere. So it's a way of doing in situ measurement of atmospheric properties from the ground. On Earth, you have the FAA to contend with, and you can't pay out something longer than 500 feet on a balloon tether, otherwise you're in danger, you're a hazard to aircraft. So we didn't get a chance to send it off that high. But what we did end up doing was going up to the limit of 500 feet on this long tether with this balloon. We managed to set the balloon up in sim. After it got dark, we took the helmets off just because you couldn't see anything, and it was dangerous to be walking out there with the helmet on when you can't see. So we managed to loft this payload, which had a GPS system, some barometric sensors, temperature sensors, and a light source on it. Part of the purpose of the payload was you send the calibrated light source up high and look at it with a telescope from the ground. Any difference in apparent magnitude or spectrum of the light source is due to absorption, due to fines and particulates in the atmosphere between you and the source. That gives you some idea about what's actually up there. So we managed to track it from Musk Observatory while kind of carrying the balloon by the tether way out into the plains to the east of the habitat, which is a lot of fun. And this is why Heidi and I were laughing at your drill centrifuge. We ended up having to do very much the similar thing with Lambda. The problem was, like you probably saw in that picture, was the slurry kept settling at the base of the fuel cell, which is something we hadn't foreseen. We thought it was going to stay in suspension. But the microbes won't work. They won't produce power if they're not in suspension. So we needed to find a way to keep them in suspension by stirring the cell. If the cell's a closed thing, you can't stir it without opening it up and breaking the experiment. So originally we just had people coming downstairs every so often and turning it over and shaking it, but that wasn't very scientific. It wasn't repeatable. It wasn't regular. So instead, what we ended up doing was actually breaking open a sawzall, tying it to a stepladder, like you can see, and then attaching the sawzall to a hole we cut in the side of the fuel cell. And then just every so often you come down here and you turn the sawzall on, and it boom, 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 it shakes the entire table in a very loud but very repeatable way. So we managed to keep the slurry in suspension just by basically shaking the cell back and forth with the sawzall every so often. So the fact that you had to do a very similar hack when you needed a centrifuge, I mean, that's good. It's good that MDRS is making us do this. Because these are trivial problems in a lab facility that could become life-threatening if this had been something like a life support system that needed a solution like this on Mars. And that's what the analog stations are so good at, is teaching you to do what would normally be a trivial effort with resources that you have on hand.
There's actually a kind of a contention in the Mars Society between the engineering people who say, please keep your mitts off our tools, and the scientists who end up retrofitting things like this. And that's part of the reason they were very happy that I brought my own drill, because the previous crew had used the hammer drill from HAB.
Well, you use what's there. That's why it's there, and
Exactly.
And the junkyard becomes your best friend. I mean, we went out there and salvaged materials to make this work. by going through what was scrap. So it's amazing what you can do when the resources are limited the way they are at the analog stations. And then the last thing we did, we were there over Super Bowl weekend. So even though you're not supposed to go out, everyone on EVA, you're supposed to leave someone behind at the hat, but we only had 6 people, and you can't play a fair game of football with only 5 people. So we went out, all 6 of us, and played the first Martian Super Bowl. Conveniently, we had 3 scientists and 3 engineers. So we managed to play football in sim, we should mention, which is, I mean, it proves the suits are inconvenient, but not so completely inconvenient that you can't throw a football, even given the fact that already between us we had 1 football player between all 6 of us, and 1 rugby player.
Which is way more than I would have expected for a Mars crew.
Yeah, Kevin was actually a quarterback, surprisingly enough. Of course, a quarterback is no good unless someone else has played football before. Actually had to explain to Sucrete what you're supposed to do with the football after you get it.
You gonna tell us the score of the first Martian Super Bowl?
I must say the engineers beat the scientists very, very much. So.
Only by 1 touchdown,
Was
actually.
it by 1?
Yeah, by 1
Well,
touchdown.
That's a lot more gloating.
That's
than
not
that.
embarrassing.
No,
That's
it
a good
was-
show.
Yeah,
it was a good showing.
Part of the problem was so Kevin was the engineer, so we had him on our team, and the quarterback for the scientists was a rugby player.
Mhm.
So it's hard to convince her that you can throw down the field. You don't have to lateral always to the people behind you. But it was fun, and that was the point. We managed to play the first Martian Super Bowl.
Yeah, we made it up to, not just from the physical standpoint, but with the food study that we were doing, we were able to make Super Bowl type food. We made the cheese dip from the Velveeta we had, and made
Which was
tortilla
quite good.
chips from the, and I mean, we went full scale with this just to kind of give us that home touch feeling, which is important,
Yeah.
especially for a long-term trip. I mean, you gotta remind yourself of what you're leaving behind and make up your new tradition. So it was something that was very practical for us and gave us a good time.
Yeah, I mean, Chicago deep dish pizza is fantastic, but when you spent 2 weeks
Right.
eating rehydrated food, it's amazing what good pizza starts to mean. Yeah, here it is. We have that.
We are very fortunate to have a French woman on the crew who came to making dehydrated food into crepes.
Oh, yes.
It's a matter of national pride.
Yeah, I definitely learned how to make tortillas while I was there. It was pretty good. The year we went, they were doing the full food study where they gave us this, an alternation between dehydrated food one day and homemade food the next. This is our pizza creation that we created. Interesting taste. But overall, it was a great experience. We learned a lot. Going back to some of the dangers of the real world. I mean, we probably were the cause of some of those ATV acts not working too well. I know I flipped one, someone else flipped another one.
I didn't flip the ATV, but I did
Yeah.
flip myself. I took
Yeah.
it over a hill too fast, didn't see there was a ditch on the other side.
Yeah.
The ATV nose planted, and I cartwheeled right over.
Yeah.
We did not, we lost a helmet, but that was due to somebody, by the time we were out there for this thing, they changed the policy that you are allowed to put on a real motorcycle.
Right.
Yeah, that's it now. Whenever you go out,
So,
you're wearing these.
one of the crew had strapped the EVA helmet to the back and fell off. So that got damage. But yeah, those ruts, back when I was there the first time, we were able to just drive wherever. So if a rut was in the road, whatever, just go around. Now you were actually kind of required to porpoise through those things
Right.
and back roads.
Yeah. One of the projects, I kind of had some downtime with my project, so we went out a few times. There are roads that are established there that you're supposed to use, but we were the second crew, I think, of the winter. So a lot of them had been washed out. So we made a project of taking GPS and going out and finding intersections, which allowed us to go and travel in different places and kind of see where we were. But we did map out all the roads and locations, the intersections where everything was. So.
There generally is just posts. And
Yeah.
you barely see through that crappy helmet.
Right.
From post to post. But
Yeah.
generally what we kept doing was the Bureau of Land Management, or maybe it was the local ranchers, would take the horses down those roads. So you'd look for the horse prints. You'd look for the hoof prints. And, okay, that's where I'm supposed to go with my space.
Yeah.
So yeah, so it's obviously, it's a great facility, and I'm sure if Mars One manages to make it to the training stage where there's actually a crew to be trained or crews to be trained, I'm sure the analog habitats will be where part of that training takes place, given the Mars Society's heritage and experience with analog environments.
And the thing that I'm working on with Jakob is there's a group in the Atacama Desert that want to make another app. And the thing I'm designing, if they like it and if we need any funding for it, this is still please sign a non-disclosure so I can, otherwise I won't tell you all the details. It's all the capabilities of MDRS, but the comfort level is far higher. And it just happens to be the right scale for Mars One. So instead of living in little tubes off the back of Red Dragon capsules, this would be something that could theoretically be built by robots. And they would just move in, and it would be a lot more like living in a resort than living in a tube. And it's fully capable and very structured.
That's actually the biggest question I've had on all this is this idea that the robots are going to be able to set things up. How plausible is that?
Well, it depends what I'm sure you'll go into this, but I know NASA, they created the athlete. I don't know how much you know about that, but I mean, it's a hexagonal, 6-armed. It's got the capability of picking up capsules, putting it on top of it, and moving. And then the arms can independently work itself, pick up tools completely. So we have the technology, and they have working models of that. They've created that technology. So
Is it autonomous or?
it is. It's completely autonomous. It just.
I mean, you program it and then let it do its thing?
Right.
Or is there?
The original mission profile for it was, do you know the Altair landing craft? It was meant to be the lunar landing module equivalent to Orion's capsule. The idea was, after the lunar lander has come down on its landing stage, you want to get it off and you want to put it somewhere where you may not have actually landed. And the idea was that's what Athlete would do, is it would lift the entire habitable stage of the lunar lander off the landing stage, put it down on the ground, and put it on top of a wheeled chassis or something like that.
And the thing about lunar operations is 1/7 gravity. On Mars, it's 40% gravity. So you've got that dichotomy where it's at least twice as much as what it went from the moon, but it's still better than still less than half.
One question that came in from the internet group was, well, two questions that I can think of right off the top of my head. One was, how close does MDRS simulate the Martian environment? Do they make it go the extra mile to make it close? Is it a separate atmosphere within the capsule, or is it just a unit?
No,
It's not that strict.
the habitat itself is not airtight, but the geologic environment, I mean, it's pretty much as good as you can get on Earth, with the exception of the high Arctic.
There's, I think they've identified about a dozen good analogs. Atacama is the one. MDRS is probably the best overall. I mean, it was really fascinating when I was there the first time. That was the first time in history that you got different pictures of Mars every day because the rovers moved. Before that, Viking took the same panorama, over and over. It's like, oh, here's the thing that crossed. Oh, here's the sunset. It was the same view every day. It's the old joke about if you're not the lead dog, the view never changes. And so there was like this little ridge of a hard material that was sticking out like a spine that I saw at MDRS, and I saw either the day before or the day after Curiosity, or not Curiosity, but Spirit had sent a picture of the same thing. And I was like, well, that really did a lot to. The real question is, how well can you suspend disbelief? And we were lucky to be a crew that was there just as Spirit Opportunity were getting going. So it was a lot easier to suspend disbelief when we were getting pictures back from Mars that we could look at over the internet and the HAB and see the same things that we were seeing inside. And usually it just happens in real brief flashes, like you're in the spacesuit and everything, and your brain is saying, I'm in Utah. And then one of my crew members was like, I really feel like I'm on Mars. And it's like, okay, fine. The next day, I go out in my spacesuit and a dust devil went by. And it was right around the time we were starting to see dust devils on Mars. And just for about 3 seconds, it was like, this feels real.
It's very easy to pretend at night. It was the best night sky that I'd ever seen. The dryness, the altitude. I mean, I grew up in Colorado and we didn't have skies that good. And when it's dark, you can't see the terrain. All you can tell is you're in a spacesuit, you're in a desert, and there's a beautiful night sky above you. It's very easy to pretend on Mars.
How extensive have there been attempts to grow food in that greenhouse, or is that beyond the scope of what that station does?
When they were there and when I was there the first time, it was not for that purpose. It was for water filtration. Now they've basically said, one, it's not very good for that, and two, it's as long as we got this greenhouse there and we're doing food studies, we've learned everything we're going to learn about the water filtration, so let's just move on. So it is now a real greenhouse. There is a little bit of a water plant exhibit for everybody, the rest of it's food. And we were able to main thing you can grow in a hurry is bean sprouts, because they're ready to go and eat in a few days. So you can plant them and harvest them 5 days later. The other thing is that there were little salady sort of plants there where you could just sort of pick stuff off and leave the rest of the plants. So we got really tiny salads every so often that were grown locally. Any other questions?
Are they doing everything that you saw in the greenhouse over there as hydroponics or dirt? Did you notice?
When I was there, it was dirt.
It was all dirt.
There is that. I didn't know.
Just curious.
Very nice meeting you all.
Thank you for coming. Well, 2 weeks isn't terribly long, and it sounds like you had pretty good team, but did any of the isolation set in for any of the team members, or did that have too busy?
My bigger problem was I'm more of an introvert, and being commander and being an introvert are not the best combination when things are going horribly wrong. And the other thing is, at the time I was living alone, and so going from being alone to having 6 other people on top of you 24/7 did not really give me a chance to recharge my batteries. So there were times I would intentionally not go on EVA just to have some downtime, to try and gather my thoughts as to what we're going to do next. Because the thing about being commander is that you wake up in the morning like maybe an hour before everybody else, and I was still in my pajamas at 2 in the afternoon and did not even brush my teeth, and I was like, this is disgusting, because I had not had 5 seconds to myself. It's just, we got to do this, okay. Send the kids off to school in their spacesuits, and okay, now I can actually take time for hygiene. So.
It didn't really happen with us, but we had the advantage that we had all worked together before. All 6 of us were part of the original group that had done NASA Academy together, and NASA Academy is meant to weed out any personal issues between people. It's meant to turn the group into a perfectly functioning team. So we'd already figured out who was the introvert, who might not be able to work on this project with this person for this amount of time. So I'd say we had pretty much a perfect group chemistry and a perfect working environment.
I think also having we were talking about the staterooms, it was really important to kind of have your own space that you can make yours and you can include to if you needed to for a couple of minutes. But having a busy schedule throughout the day, like you're saying, you wake up, you have a meeting of what you're doing in the day, you make breakfast, you go out on EVAs all day, you come back, you sit down, you talk about what you did, you plan the next day's mission. That structure is very important because it takes out boredom. It takes out the time to sit around and think, oh man, I wish I was doing this or this. You have a planned, structured day that keeps you going, that allows you not to kind of think about everything else. So, and that, even on real Mars, that's going to be happening because everything outside is something you've never seen before. You're bringing back samples, you're doing experiments, you're running other people's experiments, your own experiments. Just taking care of the hab, doing your engineering stuff. I mean, every person has a part and everyone has something to do at all the time. So there's really not thus, oh, what are we going to do today? It's like, no, let's go and do it. So.
Other than the Super Bowl, did you guys have any other scheduled recreational time?
By different cruise. We found one from the, 40s or 50s.
The most cheesy Mars Invaders sci-fi flick you can imagine, like Mystery Science Theater worthy.
Yeah, and we all sat around, we picked a day on the schedule, we all sat around and watched the movie together on the laptop. So we did, as a group, we kind of planned things throughout the day, throughout the week.
Did you notice
come together.
the lost logo from?
Oh, yeah.
No, it didn't.
That's a joke from, I never watched Lost, but I remember the logo.
That's funny.
But speaking of Mystery Science Theater, we actually had a very direct Mystery Science Theater tie-in on my group. Because I didn't just bring the squirrel, I also brought a book by Mike Nelson called Death Rat. And I got this book unexpectedly because we hosted Mystery Science Theater night at our house in St. Charles. I did not know until this week that Mike Nelson was born in St. Charles. I mean, he grew up in that area because he makes a very specific reference to the very neighborhood he lived in the show one time. And he was like, yeah, as a kid, I was walking from Geneva to St. Charles. And he's talking, and he's describing everything, and we're just like, our eyes are getting very big because he's describing what's just outside the apartment in detail, accurately. But anyway, so we hosted this movie night there, and then they had him as the guest of honor at a Mensa convention in Arizona. So they were excited to get us down there and stuff like that because we hosted this thing. And for whatever reason, I think we had some conflict with the wedding or something, we actually could not go to the convention. So a year later, after we totally forgot about this, I get this package in the mail. I open it up, it's Mike Nelson's Death Rat. I open it up, and it says, on the autograph page, it says, "Dear Ken, where the hell are you, Mike Nelson?" So I took that with me to MDRS because of the whole situation with Mighty Martian Mouse. And our press embed from London was informed by our veterinarian that he had to sleep up where the rat had been. So he got up one morning and he said, "I am a rat, and there's humans sleeping with me." So he took it in good form. And at one point I said, I'm sure you're nervous sleeping up there with a trapped wild animal and so forth. So I want to give you some recreation and we need to calm him down. I would shove him down. Just looks like a death rat.
Humor keeps people sane, even in the most tightly controlled environments. There's a good reason why Mars One is asking, describe your sense of humor. That keeps people sane when otherwise they try to open the airlock with outer space
Were there any other questions from the online community?
Not for this segment, no.